Today we're going to look at Experiment 5, mole calculations. So for this experiment, we're going to be using the periodic table, using these masses on the periodic table to calculate between grams, moles, and particles. So let's look at the lab. Let's keep in mind, here in bold it says, use 4 significant digits for all calculations. Show your work and setups for each calculation. Answers only will not be accepted. Okay, so use those 4 significant figures. Show your work. That's worth points as well. So what are we doing for this lab? Well, basically, we're going around and we're taking the mass of several different objects that are made up of different elements. So since you're not here in lab, what I have done is I've massed these objects myself and filled in the tables. So for station 1, I took a lead cylinder and massed it, and the mass I got, mass of the lead sample, is 63.2 grams. That's how much the scale read when I put that object on the scale. Now what about this first part up here? It says the mass of 1 mole of lead is. So how do I figure that out? How did I get that 207.2? Well, when it asks for the mass of 1 mole of lead, what it's asking for is the molar mass. So what is molar mass? Molar mass is the average atomic mass that we find on the periodic table, and its units are grams per mole. So when it asks the mass of 1 mole of lead, I look up the molar mass on the periodic table, and I need to find lead. So finding lead on the periodic table, the symbol for lead is Pb. So here I see it right here, Pb, lead. And the atomic mass is the mass that's below the symbol, the decimal point number. So it's telling me the molar mass of lead is 207.2 grams per mole. And what this means is that there are 207.2 grams in, so per mole, per 1 mole of lead. So 1 mole of lead will weigh 207.2 grams. So this question here, the mass of 1 mole of lead is 207.2 grams. So whenever it asks for the mass of 1 mole, it's just asking you to look up that symbol on the periodic table, find what its atomic mass is, and then write that number here. So the mass of the lead sample, I give to you based off of what I got when I weighed that actual sample on the scale. So let's look at the next calculation that they ask us to do. So the next calculation wants us to calculate the number of moles of lead in this sample. Okay, so they're asking, given this sample, the 63.2 gram sample of lead, how many moles are there? Well, this is where we can use our equation sheet that I posted on Blackboard, and if you're in my lecture portion of the class, you'll have access to it as well. And they're asking us to solve for moles, so moles is equal to mass in grams divided by molar mass, which is grams per mole. So whenever they ask you to solve for moles and you are given the mass, you would take that mass and divide it by the molar mass of that element or compound. So in this case, what we would do is take the mass, and the mass that we're using is the mass of the lead sample, the 63.2 grams, and we're going to divide it by the molar mass. And remember, molar mass, to figure that out, you're looking at what material, what element, what compound. In this case, it's lead. and we already wrote down the molar mass of lead. It's right here, 207.2. So we're going to take 63.2 divided by 207.2. Units on molar mass are grams per mole, so the grams are canceling, giving us units of moles for our answer, which is good. That's what we want. When we divide that out, we get 0.3050 moles. Remember, I used 4 significant figures. That's why I added that 0 at the end, because all answers need to have 4 sig figs. Now for the next one, it asks you to calculate the number of lead atoms in the sample. So when we're talking about atoms, we're going to look at the equations that have the words entities in it. So entities can be atoms, molecules, or formula units. We use the word atoms when we're referring to an element. We use the word molecules when we're referring to a compound, a covalent compound. And we'll use the term formula units when we're referring to an ionic compound. So they're saying atoms since it's an element. Now to solve for atoms, we're going to look at the equation, number of entities, in this case atoms, is going to equal to, whenever we're solving for atoms, molecules, or formula units, we're going to be using Avogadro's number. We're going to take the number of moles and then multiply it by 6.022 times 10 to the 23rd. The units on that are atoms per mole. So this is the equation that we want to use, and what we're going to do is we're going to plug in the molar amount that we solved for in the previous problem, which was 0.3050 moles. So we're going to take that and plug it in where the moles is. And then multiply that by Avogadro's number. Moles and moles are canceling. So when we multiply that across, we get 1.837 times 10 to the 23rd. Units on it are atoms. So let's look at Avogadro's number quickly in case you haven't covered Avogadro's number in class yet. So when I say Avogadro's number, I'm referring to this 6.022 times 10 to the 23rd. Notice, this is a very, very large number. It's written in scientific notation. It's got that times 10 to the 23rd. So this times 10 to the 23rd, since it's a positive exponent, that means we're moving this decimal point 23 times to the right. So this is a huge number in the order of trillions or larger even. So what Avogadro's number is it defines a mole, defines the word mole. So Avogadro's number says that there are this many atoms or molecules or formula units in 1 mole of any substance. So it doesn't matter what the substance is. So we just looked at lead. So what this is saying is that if we had 1 mole of lead, there would be 6.022 times 10 to the 23rd atoms in that 1 mole, atoms of lead in that 1 mole. If we had 1 mole of carbon, there would be that many atoms in that 1 mole of carbon. Okay, I often equate this to the term dozen. So if you have 1 dozen of something, that means you have 12 of something. Just like if you have 1 mole of something, it means you have 6.022 times 10 to the 23rd of something. And when I say something, what I mean is it doesn't have to be eggs when you refer to dozen, right? You could say, I have a dozen pencils. And that means that you have 12 pencils. I have a dozen cups. That means you have 12 cups. So we're using Avogadro's number in the same way. If you say you have a mole of something, anything, you could say, I have 1 mole of sugar. Okay, that means you have 6.022 times 10 to the 23rd molecules in that 1 mole of sugar. So that's how we're using this. So when it asks us to calculate the number of atoms in the sample, if we know the moles, we can use this like a conversion factor, in this case by multiplying by Avogadro's number. We cancel out the moles and we're left with the atom amount. So you're going to be doing these same steps for stations 2 all the way through 4, so the exact same steps. So let me go ahead and show you the data so you can fill that in. So for station 2, this time they're looking at copper. So when it asks for the mass of 1 mole of copper, it's just asking you to look at the periodic table, find copper, and write down its molar mass. For the mass of this copper sample, this is where I took an actual cube of copper and weighed it out on the scale, and I got 45.6 grams. So you can go ahead and fill that in. For the calculation of the number of moles of copper, you're going to follow the same steps that we did up here in station 1, using the equation where moles is equal to mass divided by molar mass. Keeping in mind that this value here that you found on the periodic table is the molar mass, and this value here is the mass. To calculate the number of atoms of copper, you're going to use this equation up here. Number of atoms equals moles times Avogadro's number. And when you do this calculation, just like I did up here, I did 4 sig figs, but also make sure you're writing that times 10 to the 23rd portion. That's important because it's saying that this is a very large number. Atoms are extremely small. So if you had a whole mole or even just a few grams of a substance, it's going to be billions upon billions and trillions of atoms. Station 3 is asking the same thing. Let me move this down a little bit. Except for this time we're using tin. So you would find tin on the periodic table, write the molar mass of tin here. The mass of the tin sample that you're going to be calculating the moles and atoms of is 63.6 grams, so go ahead and fill that in. You're going to calculate the moles and the number of atoms using the same equations for station 1 and 2. Station 4, this time aluminum. So find aluminum on the periodic table and write the molar mass here. The sample that I massed on the scale of aluminum was 66.4 grams, and you will be calculating the moles and the atoms once again. Now let's look at station 5. This station is a little bit different. So this time we have an alloy. So what an alloy is it's a mixture of 2 or more substances together. So in this case we're looking at an alloy of brass. So brass consists of 67% copper by mass and 33% zinc by mass. So since it contains 2 different elements, you need to look up both those elements, zinc and copper, on the periodic table, and in these spaces you're going to write down the corresponding molar mass of each of those elements. Now that sample of brass that I weighed was 207.8 grams. Before you can calculate the moles or the atoms of either copper or zinc in that sample, you first need to calculate how much of that 207.8 grams is copper and how much of that is zinc. Well, they told us. They said 67% of this total mass is going to be copper, and the other 33% is going to be zinc. So to figure it out, you're going to take the mass of the brass sample, 207.8, and multiply it by the percent of it that's copper. And we just said it was 67%. But when I multiply it by 67%, I'm going to put it in a decimal form, not in the percent form. So multiply it by 0.67. And that will give me my mass in grams of copper. So how much of that 207.8 is copper? You're going to do the same thing for grams of zinc, except for 33% of that 207.8 is zinc. So you'll multiply by 0.33 for this one. And when you add these together, they should equal 207.8 because these are just parts of the whole. So whatever you get for these mass amounts here, you're going to be using those to calculate the moles and the atoms in the same way that we did in the other stations. It's just now you have two elements to do it for. So to calculate the number of moles of copper in the brass sample, you're using the same equation that we did before, where you take mass divided by molar mass. But you want to use the mass that you calculated using that 67%. The molar mass of copper you should have written up here, and that's the number from the periodic table. You do the same thing for zinc using this gram amount and the molar mass of zinc. For the number of atoms, you're going to take the moles that you calculated in these two problems here and multiply by Avogadro's number. So this would be copper moles and then zinc moles here. All right, looking at the next station. So in station 6, this is the first one where we aren't given an element, we're given a compound now. So in this case, we're given sucrose, which is sugar. They give us the chemical formula C12H22O11, sorry. So we have to calculate the mass of 1 mole of sucrose. So in order to do that, we have to calculate molar mass. So to calculate the molar mass, and I'm not going to do this exact one, I want you to do that on your own, but I'm going to do a different chemical formula just to show you the steps. So to calculate molar mass, you always want to take, you first need the chemical formula, and you're going to make a list of all elements in the chemical formula. You're going to write the number of atoms of each and multiply by the mass on the periodic table. You're going to do that for each element present. So how does that work? Well, I'll do a similar one. Let's do C6H12O6. So how do you know how many atoms? Well, first, let's make our list of all the elements present in the compound. So we have carbon, hydrogen, oxygen. So my list, carbon, hydrogen, oxygen. For the number of atoms, we're looking at the subscripts, the little numbers that come after each. So there are 6 carbons, 12 hydrogens, and 6 oxygens. So carbon, 6 atoms, hydrogen, 12 atoms, oxygen, 6 atoms. Now the mass portion, we go to our periodic table to fill that in. So looking up carbon on the periodic table, its molar mass is 12.01. Hydrogen, 1.008. And then last but not least, oxygen, 16. So now we're going to multiply across. We have 6 times 12.01 gives us 72.06. 12 times 1.008 gives gives us 12.096. And oxygen, 6 times 16, gives us 96. Now, we need to make sure, do one last step, and that's add that total, because we want the total molar mass of that entire compound. So we need to add the carbon and the hydrogens and the oxygens all together. I get 180.2. So the reason I rounded it is because they said that they wanted all answers to have 4 significant figures. So I rounded it to 4. The units on it are grams per mole, because we use this to convert between grams and moles. So you're going to do the same steps, but using this chemical formula to calculate the molar mass of 1 mole of sucrose. Okay, so these numbers will be the same, the masses. It's the number of atoms that are going to differ. So use this chemical formula and fill in the atoms and do those calculations. Now, this value here, the 111.25 grams, that's how much the sugar that I massed out weighed. Okay, so it was 111.25 gram sample. Now, you just do the steps that we did before. So calculating the number of moles of sucrose. If you want the number of moles, you take the mass divided by the molar mass. Mass is that 111.25 grams. The molar mass is whatever you calculated here using this chemical formula and the steps I just showed you. Next, it asks for the calculation of the number of molecules. Okay, so far we've only calculated the number of atoms. But remember, when we use Avogadro's number, it can be atoms or molecules or formula units. So the reason that now they're using the term molecules instead of atoms is because we're not looking at an element by itself anymore. Now we're looking at a compound, and more specifically, a covalent compound, because they're all non-metals. So when we have a covalent compound, the term molecules is used. The calculation is the same, it's just a different term. So we're still going to be taking, to figure out the number of molecules in this case, we're still going to be taking the moles that we calculated up here and multiplying it by Avogadro's number. Now this next question has a student placing 15.56 grams of sucrose, and that's just sugar, in a cup of coffee. How many moles and how many molecules of sucrose were placed in the coffee? So it's asking you to do these two calculations, but with a new mass now. So you're going to use the mass of 15.56 grams and calculate moles using this equation here, and then you're going to calculate the molecules using that new molar amount. So it's basically these two steps, but with a new mass. Station 7 is going to be the same, except for this time we're doing table salt, sodium chloride. So when it asks you to calculate 1 mole of NaCl, you're going to do the same steps for molar mass. Make a list. You have sodium, you have chlorine. How many atoms of each do you have? And then look up their masses of sodium and the mass of chlorine on the periodic table. Add them together to get your total molar mass. You're going to use that molar mass in the next calculation. The mass of the sample was 72.91 grams. So to calculate the moles, you're going to take that 79 or 72.91 grams and divide it by the molar mass that you calculated up here. Calculating the number of formula units. So notice just a different term. Now we're looking at an ionic compound, a metal with a non-metal. So instead of using the word atoms or molecules, they're just using the term formula units, but it's the same calculation. So to calculate the number of formula units, you're going to take the moles that you calculated here and multiply it by Avogadro's number. Once again, they have just a little extra problem there for you to get more practice, giving you a new mass amount of 25.25 grams, excuse me. So she's putting a lot of salt on her French fries, and they want you to calculate the number of moles. So you'll use this mass in this equation and the same molar mass that you calculated up here because it's the same compound. And then also calculate the formula units, doing this calculation with your new mole amount. All right, the last two are just calculation only, so there's no data that I give you for them. You just use the information in the questions itself to solve. So for the first one, the experiment requires you to react 3.538 moles of water. So calculation of 1 mole of water, that's the molar mass. So you're going to take the number of atoms multiplied by the mass on the periodic table. You have hydrogen, you have oxygen, because we're using this chemical formula. Use the subscripts to figure out how many atoms of each, and then use the periodic table to figure out the masses. Now it's asking you how many grams of water. So now we're solving for mass. So when we solve for mass, when we're given the moles and the molar mass calculated here, this time instead of dividing, we're going to multiply. So we're going to take the moles that they gave us in the question, the 3.538, and multiply it by the molar mass that you calculated here using the chemical formula. And that will give you the mass in grams. Don't forget about the 4 sig figs. Next, it says if water has a density of 1 gram per mil, how many mils of water should be measured to perform this reaction? Well, density, a little bit of a review, but we did density before. It's mass divided by volume. We also looked at this triangle, right? The DMV triangle. So in this case, it's asking you to solve for V, volume, milliliters, right? So if you need to solve for volume, you're going to take the mass divided by the density. You have the mass here, the density is given to you here. For number 9, a certain volume of an alcoholic beverage contains 15 milliliters of ethyl alcohol. It gives you the chemical formula of ethyl alcohol here. If ethyl alcohol has a density of 0.791 grams per mil, calculate the number of grams of ethyl alcohol in the sample. Okay, so this time they're giving you volume and density, and they're asking for mass. So use your density triangle. You're solving for mass this time. So in this one, you will get mass in grams will be your final answer. So you're going to be using that to help you calculate the number of moles down here. But before we can calculate the number of moles down here, we first need the molar mass. So this calculation of 1 mole, they're really just saying calculate the molar mass. So you're going to do the same thing where you make the list of all the elements present. So we have carbon, hydrogen, and oxygen. Write the number of atoms of each using the subscripts. That's a 2, that's a 5, a 1, and a 1. And multiply by the mass that you find for each of these elements on the periodic table. The units on it are going to be grams per mole. Now, once you have this, you can move to the next problem, which is calculating the number of moles in this sample. So we've done this several times already. We're taking the mass in grams divided by the molar mass. The mass in grams you would have figured out up here using the density equation rearranged. The molar mass you have calculated here, so just plug them in. Now again, it's asking for molecules. So whenever you see the word atoms, molecules, formula units, you're using Avogadro's number. So you're taking the moles that you calculated up here and multiplying by 6.022 times 10 to the 23rd. Now, the last question is asking, is ethyl alcohol a covalent or ionic compound, and how do you know? So I will leave that for you to answer, but whichever one you choose, covalent or ionic, explain your answer. That's worth 2 points right there. One for the correct answer, covalent or ionic, and then another point for your explanation.